Hello, welcome everybody. We are going to be talking today about the modulus. I have been getting many questions from my students about the modulus. What does it mean? How do we solve it? So today we're going to do like an intro lesson to modulus, just recapping what it is, what it means, how do we use a formula to find it, and then in my follow-up video we'll be looking at some slightly harder examples, exam-style questions and such. So let's get straight into it. Of course, we're in the topic of complex numbers. So what is the modulus? Well, by definition, the modulus, which we denote with these little kind of absolute value signs, it is the distance of a complex number, which we use Z to represent a complex number. It's the distance from the origin. That's the definition. So if we visualize this a little bit, I have my complex plane, I have some complex number Z, and I want to know the distance to the origin, which is the center of my graph. And the typical way that we do this is we line it up down here and we use our right angle triangle knowledge. So Z we would usually use as x plus iy, where this distance across here would be my x, this distance up here would be my y, and we are trying to find this long distance. Often we use r, mainly because we use that in polar form, to mean that length. So that's our job. Let's do a few examples to see. Obviously, if you can see a right angle triangle with these three sides, hopefully your brain has already triggered that the formula we're going to be using is Pythagoras. Let's look at some examples real quick. I've set some up. All right. Let's do a few just basic examples. How do we calculate the modulus? So how would I calculate the modulus of 2 plus 3i? So first of all, we'll plot that. Go across 2, up 3i. Here is this particular complex number, across 2, up 3i. I connect it to the origin. I connect it to the x-axis, and I have a triangle. Personally, I like to draw this triangle out separately, so I'll just draw it out again over here. Not perfect, but I'll put my links on it. 2 here, 3 here. R is what I'm trying to find. I'm going to use R the whole way through this as my modulus, and so it's directly Pythagoras theorem. R squared is equal to 2 squared plus 3 squared. Some quick maths in my brain here. This is going to be 4 plus 9, 2 squared and 3 squared, so we've got 13 here. And then lastly, I square root to get r. R is the square root of 13. So the modulus of 2 plus 3i would equal to the square root of 13. Let's do another one. Minus 1 plus 2i. So I'm going to plot it. Across 1, negative, and then up 2i. So I'm going to be here. Negative 1, 2i. And I want to connect it with the origin. And I always draw it down along my x-axis, so the triangle comes down like this. Again, I'm going to draw that triangle separate. But this distance is 1, and this distance is 2. Notice I haven't labeled that side negative 1, even though it has gone across negative 1. This is the reason why I like to draw my triangle again, is I'm very careful when I draw my triangle to only have positive links. Also, notice I haven't called this 2i. Even though it has gone up 2 in the I direction, when I draw my triangle separately, I want just lengths. I don't want i's, I don't want negatives, I just want the lengths of that triangle. So imagine this triangle cut out, and just what would the lengths be? So 1 and 2, this side is my r. Again, it's Pythagoras. Now I'm going to jump closer to what the formula is. Notice that I squared both of these and then I square root it. I'm just going to go straight to r is going to be equal to, I'll do the first step, we'll get there soon. R squared is going to be equal to 2 squared plus 1 squared, and so r is going to be the square root of those two things, 2 squared plus 1 squared, and so r is going to equal to the square root of 4 plus 1, 5. So this question is going to be the square root of 5. Let's try another one. If at any moment you want to pause and have a go at these by yourself, you can, more than welcome to do that, and then jump back in and see if you've got it right. So we want the modulus of 1 minus I. First I'm going to draw it across 1, down 1, so here it is. Connect it to the origin. Connect it to the positive real axis, or just the real axis, actually in this case it's the positive, and I'm going to draw this triangle out again, where this distance is 1 and this distance is 1. I've gone across 1, I've gone down 1. But without taking my negatives, it's just a 1 and 1. This is my R. So jumping to my step here now, because this is getting closer to actually what the formula is, R is going to be the square root of 1 squared plus 1 squared. And so R is equal to the square root of 2. 1 squared is 1 and 1 squared is 1. Add them together, 2. So the modulus of that is the square root of 2. All right, some easier questions actually here. So if I want to know the modulus of minus 3i, I'm going to plot it. Here it is here. Sorry, no, that is negative 3. Negative 3i will be here. Now, here's my origin. If I connect it to the origin, we're here. There's no triangle here. So it's actually, we do not need Pythagoras for this question. It's literally how far have I traveled to get from here to here. I don't care about negatives. I don't care about i's. Literally, if I count squares to get from here to here, how far did I travel? I traveled a distance of 3. And that is my modulus. Literally, how far away is this point from the origin? We do not care about direction. I only care about distance traveled. And last one, similar question. What about the modulus of 4? Plot 4, 1, 2, 3, 4. Here it is. I want to travel that distance. I don't care about direction, so that is going to be 4. All right, so hopefully this was helpful. From this, there is a formula for how we calculate the modulus to do with Pythagoras, and that is the modulus of z, where z is some complex number, is equal to x squared plus y squared. The real thing squared plus the imaginary squared. And that is our formula for modulus. If you would like to see some harder questions, some exam style questions, click on the next video and we will look at that. Hopefully this was helpful. Feel free to like, subscribe, and cool. See you later.